Welcome to Astronomy Daily, your daily dose of everything happening beyond our atmosphere. I'm Anna, and I'm thrilled to have you join me for today's cosmic journey through the latest developments in space exploration and astronomical research. We've got a packed episode for you today with some fascinating stories spanning from our nearest celestial neighbor all the way to the ultimate fate of the universe itself. First up, we'll dive into what exactly caused Intuitive Machines' second lunar lander to topple over when it touched down on the moon in March. The company has identified several factors that contributed to this unexpected landing position, including some interesting challenges with their laser altimeters and the tricky lighting conditions near the lunar South Pole. We'll explore how they're planning to address these issues for future missions. Then, we'll look at how Intuitive Machines is diversifying beyond just lunar landers, especially as NASA's Artemis program faces potential major changes under new budget proposals. It's a fascinating look at how commercial space companies adapt to shifting priorities in space exploration. Next, we have some mind-bending research about the ultimate end of the universe. Scientists from Radboud University have revised their predictions about when and how the cosmos might meet its final demise. Spoiler alert, it's still an incomprehensibly long time away, but apparently sooner than previously thought. We'll break down what this means and the science of Hawking radiation that's driving these new calculations. We'll also check in with the crew aboard the International Space Station, where the Expedition 73 team has been busy with biotechnology experiments and important research on how fire behaves in microgravity. Their findings could have significant implications for fire safety both in space and here on Earth. Then we'll mark a historic milestone in satellite navigation as the European Space Agency bids farewell to its first ever decommissioned Galileo satellite after 12 years of service. It's a reminder that responsible space operations include not just launching new technology, but properly retiring old satellites as well. And finally, we'll explore fascinating new research, suggesting that life on Earth may have emerged remarkably quickly after our planet formed. This study provides the strongest evidence yet that the process of abiogenesis, the development of life from non-living matter, might be a relatively rapid phenomenon under Earth-like conditions. The implications for the search for life elsewhere are profound. So buckle up for a journey across the cosmos as we explore these stories and more on today's episode of Astronomy Daily. In what has become a cautionary tale about the challenges of lunar landings, Intuitive Machines has now revealed exactly what caused their Nova C lander to fall on its side during its touchdown in the moon's south polar region this past March. The company executives disclosed three key factors during a May earnings call that contributed to what they diplomatically termed a landing anomaly. First, and perhaps most significant, were issues with the lander's laser altimeters. According to CEO Steve Altimus, these crucial instruments experienced signal noise and distortion during the final descent phase. This interference prevented the altimeters from providing accurate altitude readings. Essentially, the spacecraft couldn't properly determine how far it was from the lunar surface as it approached touchdown. The second factor involves the unique lighting conditions at the moon's south pole. Unlike equatorial regions, the South Pole experiences extremely low sun angles, creating dramatic, elongated shadows across the lunar landscape. These shadows severely challenged the precision capabilities of the lander's navigation systems, which rely partly on visual references to guide the descent. Connected to this lighting issue was a third problem involving crater recognition. The unusual lighting conditions made craters appear differently at lower altitudes than they did in the reference images from NASA's Lunar Reconnaissance Orbiter. This discrepancy confused the lander's optical navigation system, further complicating its ability to execute a proper landing. The combined effect of these issues resulted in the Nova C lander tipping over upon touchdown, falling onto its side within a crater. This unfortunate position prevented the spacecraft's solar panels from generating sufficient power, dramatically shortening its mission to barely 12 hours after landing, far less than planned. Despite this setback, Intuitive Machines is already implementing changes for their next lunar mission, IM-3, scheduled for launch next year. Altimus outlined several specific improvements, including the addition of dissimilar and redundant altimeters to provide backup measurements if one system fails. These systems will also undergo more rigorous flight-like testing before launch to better simulate actual lunar conditions. The company is also developing a new lighting-independent sensor specifically designed to measure surface velocity regardless of shadows or lighting angles. Additionally, they're enhancing their crater database to improve the optical navigation system's ability to recognize lunar features under various lighting conditions. Interestingly, these modifications won't delay the IM-3 mission, though Altimus acknowledged there would be a slight increase in costs due to the additional sensors. He didn't specify exactly how much more expensive the mission would become. Meanwhile, Intuitive Machines remains in negotiations with NASA and other customers about up to $14 million in success payments related to the IM-2 mission. Despite the lander falling over, some payloads did manage to conduct limited tests. For example, a NASA drill was able to test its mechanisms, although it couldn't perform its primary objective of drilling into the lunar surface as planned. This incident highlights the extraordinary difficulties involved in lunar landings, particularly in the challenging South Polar region where NASA and other space agencies hope to establish a long-term human presence. The extreme lighting conditions, combined with the complex terrain featuring numerous craters and shadows, create a particularly demanding environment for precision landings. The lessons learned from this mission will undoubtedly inform not just Intuitive Machines' future attempts, but also the broader commercial lunar industry, as it supports NASA's Artemis program and other initiatives aimed at returning humans to the lunar surface in the coming years. Beyond their lunar landing setbacks, Intuitive Machines is actively working to diversify their space business portfolio. During their recent earnings call, CEO Steve Altimus emphasized the company's efforts to expand beyond their core lunar lander technology into other promising space sectors. One notable project involves the design of an orbital transfer vehicle based on their Nova-C lander architecture. This work is being conducted with an unnamed government customer and leverages the company's existing expertise in spacecraft design while opening new market opportunities in orbital logistics. Intuitive Machines is also collaborating with the Air Force Research Laboratory on the ambitious JETSON project. This initiative aims to develop a spacecraft utilizing nuclear electric propulsion, a potentially revolutionary technology that could dramatically increase the capabilities and range of future space missions. In February, the company secured a $10 million grant from the Texas Space Commission to support their work on a lifting body re-entry vehicle. They're partnering with Rhodium Scientific to explore how this vehicle could be used for microgravity research, potentially offering a valuable service for returning biomedical experiments safely to Earth from space. We all know the universe will eventually end, but how and when has been a subject of intense scientific debate. Now, fascinating new research from scientists at Radboud University suggests the universe's demise might arrive much sooner than previously calculated, though we're still talking about an almost incomprehensible timescale. The research team, led by Heino Falke, along with colleagues Michael Wondrak and Walter van Zwijlekam, has dramatically revised estimates for cosmic longevity. According to their calculations, the final decay of the universe could occur in about 10 to the 78th power years. That's a 1 followed by 78 zeros. While this represents a significant reduction from previous estimates, it's still billions upon billions of times the current age of our cosmos. As Falke himself put it, the ultimate end of the universe comes much sooner than expected, but fortunately, it still takes a very long time. What's particularly interesting about this research is how it builds upon Stephen Hawking's groundbreaking work from 1975. Hawking theorized that black holes aren't completely black. They gradually emit tiny amounts of radiation, now known as Hawking radiation. Over immensely long timescales, this process causes black holes to slowly evaporate and eventually disappear entirely. The Radboud team extended this principle to other dense cosmic objects, including neutron stars. Their surprising discovery was that the evaporation process is driven not just by mass, but by density. This led to some counterintuitive findings about decay timelines. For instance, despite their extreme gravitational pull and reputation as cosmic devourers, black holes share a similar decay timeline with neutron stars, around 10 to the 67th power years. That's significantly shorter than previous scientific estimates. The reason for this unexpected result is that black holes, lacking a solid surface, can partially reabsorb their emitted radiation, which actually slows the evaporation process. To put this in perspective, the researchers calculated that objects as small as our moon or even a human would take approximately 10 to the 90th power years to evaporate through Hawking-like radiation. Of course, other natural processes would end their existence long before this theoretical timeline played out. What makes this research particularly valuable beyond the cosmic doomsday predictions is how it helps bridge the gap between quantum mechanics and general relativity, two fundamental theories of physics that have proven notoriously difficult to reconcile. As co-author Walter van Zwijlkom noted, by asking these kinds of questions and looking at extreme cases, we want to better understand the theory, and perhaps one day we unravel the mystery of Hawking radiation. While none of us need worry about witnessing the universe's final moments, this research provides valuable insight into the fundamental workings of our cosmos and the physical laws that govern everything from the smallest particles to the largest structures in existence. It's a reminder that even in studying the end of everything, we continue to deepen our understanding of the universe we inhabit today. Have you ever wondered what it is that astronauts actually do all day on the ISS? I'm sure some people think they spend the day looking out the window and admiring the view. Well, far from it. Let's take a look at what they did on Tuesday this week as an example. The International Space Station continues to serve as humanity's premier orbital laboratory, with the Expedition 73 crew currently engaged in a diverse array of scientific investigations. NASA astronauts Anne McClain, Nicole Ayers, and Johnny Kim have been particularly busy with biotechnology research. McClain donned a special biomonitor garment and headband as part of an experiment monitoring astronauts' psychological responses before, during, and after their missions. This research aims to assess how space travel affects heart health, crucial knowledge as we plan for longer duration missions beyond Earth orbit. Perhaps the most intriguing experiment currently underway involves DNA-inspired nanomaterials. McClain and Ayers have been working in the life sciences glove box, mixing mRNA and protein solutions to produce special molecules formed by these nanomaterials. This research could lead to more cost-effective in-space production methods and potentially revolutionize targeted therapy delivery back on Earth, improving patient outcomes with fewer side effects. Fire safety in space represents another critical research area. Astronaut Johnny Kim spent the day installing hardware for the solid fuel ignition and extinction experiment, which includes mist systems designed to extinguish flames in microgravity. He's also working with the combustion integrated rack to better understand the fundamentals of how fire behaves when gravity isn't pulling flames upward. This research isn't merely academic. Understanding fire behavior and suppression methods in space is essential for crew safety on the ISS and future deep space missions. Meanwhile, JAXA astronaut and station commander Takuya Onishi has been focusing on similar fire safety work in the Japanese experiment module. He's been handling gas bottle exchanges in the solid combustion experiment module and performing critical leak checks to ensure safe operations. Beyond scientific duties, Onishi has tackled orbital plumbing tasks, installing recycle tanks and configuring drain valves, the unglamorous but essential maintenance that keeps the station functioning. The station's 3 cosmonauts, Sergei Ryzhikov, Alexei Zubritsky, and Kirill Peskov, have primarily focused on maintenance tasks in the Russian segment. Their work included removing cargo, replacing thermal sensors, and verifying flow sensor installations. Peskov conducted an Ethernet cables audit and worked on the intermodular ventilation system connecting the Russian and U.S. modules, critical infrastructure that ensures proper air circulation throughout the station. This blend of cutting-edge research and meticulous maintenance highlights the dual nature of the ISS as both a world-class laboratory and a habitable outpost in the harsh environment of low Earth orbit. As the crew continues their 6-month mission, these experiments will provide valuable data for scientific advancement and support humanity's ongoing space exploration efforts. I think you'll agree, there wasn't much time for just sitting and looking at the view. In a significant first for Europe's satellite navigation system, Galileo satellite GSAT 0104 has been officially decommissioned after 12 years of service. This marks a historic milestone as the first satellite in the Galileo constellation to be retired, setting precedent for responsible space operations in the coming decades. GSAT-0104 holds a special place in European space history. Launched on October 12, 2012, it was the fourth and final in-orbit validation satellite for the Galileo program. Most notably, it participated in a watershed moment on March 12, 2013, when alongside its fellow satellites, it enabled the very first position fix by Europe's independent satellite navigation system. For a constellation like Galileo, which serves as critical public infrastructure intended to provide uninterrupted service over decades, decommissioning activities are as essential as launches. The retirement process isn't just about making space safer, it's literally about making space for new satellites as the constellation requires continuous replenishment. The decision to retire GSAT-0104 came after careful deliberation by a board chaired by the EU Agency for the Space Programme, with participation from the European Space Agency and European Commission. Decommissioning activities began in March 2024 and were completed last month, in April 2025. What's particularly notable about this decommissioning is how it aligns with ESA's commitment to sustainability in space. With the growing concern about space debris threatening current and future missions, ESA has set an ambitious goal of net zero space pollution for new missions by 2030. For GSAT-0104, engineers used remaining propellant reserves to place it 700 kilometers above the operational Galileo constellation in what's known as a graveyard orbit. This exceptionally stable disposal orbit is designed to remain undisturbed for hundreds of years, ensuring it won't interfere with active satellites. The satellite was then completely passivated by removing all internal energy sources, including battery charge. This approach represents the standard disposal strategy for satellites in medium Earth and geostationary orbits, where Earth re-entry is generally not feasible. Future decommissioned Galileo satellites will be disposed at slightly different altitudes to maintain safe distance between them. The Galileo program continues to thrive despite this retirement. The constellation currently provides the same level of performance with active satellites in all prime slots, plus 3 active spares. 6 more first-generation satellites are ready for launch, and 12 second-generation satellites are in development. This decommissioning gives the Galileo program valuable experience that will prove crucial as more satellites reach the end of their operational lives in the coming years. The remaining 3 original in-orbit validation satellites have exceeded their design lifetime, but continue to provide excellent navigation performance. They'll be reviewed again in October 2025 to determine if they should continue operating or join GSAT-0104 in retirement. Galileo has become the world's most precise satellite navigation system, serving over 4 billion smartphone users globally since entering open service in 2017. Beyond consumer applications, it's making a difference across rail, maritime, agriculture, financial timing services, and rescue operations, a testament to Europe's commitment to space technology leadership. Finally, today, when we think about the dawn of life on Earth, it's easy to imagine a process that took eons, a slow, gradual emergence from complex chemicals to the first self-replicating organisms. But fascinating new research suggests that life might have gotten its start with surprising speed after our planet formed, raising profound questions about the potential for life elsewhere in the universe. A recent paper by American astronomer David Kipping titled "Strong Evidence That Abiogenesis is a Rapid Process on Earth Analogs" offers compelling analysis of when life first emerged on our planet. The evidence of ancient life stretches remarkably far back, possibly as far as 4.2 billion years ago, astonishingly close to Earth's formation around 4.5 billion years ago. The timeline is truly remarkable when you consider the evidence. Fossilized mats of cyanobacteria known as stromatolites date back 3.7 billion years. Rocks from Australia show isotope patterns consistent with biological activity dating to 4.1 billion years ago. And some ancient Canadian rocks contain tiny filament-like structures that may represent biological remains from 4.28 billion years ago. Scientists trying to understand life's earliest journey often study what's called LUCA, the last universal common ancestor. This hypothetical organism gave rise to all forms of life on Earth, bacteria, archaea, and eventually complex cells like our own. Current research places LUCA's existence at least 3.6 billion years ago, possibly as far back as 4.3 billion years. What Kipping's analysis reveals is truly significant. Using Bayesian statistical methods to evaluate the evidence, he calculates 13-to-1 odds in favor of rapid abiogenesis, the spontaneous emergence of life from non-living matter. This crosses the threshold of 10-to-1 that scientists consider strong evidence, making this the first time we have formal statistical support for the hypothesis that life rapidly emerges under Earth-like conditions. This finding addresses a long-standing concern about what's called the weak anthropic principle, the idea that we might be observing an atypically quick emergence of life simply because if life hadn't appeared early, we wouldn't be here to observe it. Kipping's odds ratio provides a more objective measure supporting rapid abiogenesis. But here's the crucial caveat, and it's one Kipping emphasizes. This doesn't mean life is common throughout the universe. Earth-like conditions themselves may be exceedingly rare. As he writes, our result does not establish that life is common, since Earth's conditions could be incredibly rare. There's also an intriguing tension within these findings. If life started so quickly, why did it take roughly 4 billion more years for intelligent life like us to evolve? With our sun expected to make Earth uninhabitable in about 900 million years, as it grows 10% more luminous, there seems to be a narrow window for intelligence to emerge before a planet becomes too hostile. The most humbling aspect of this research remains our limited sample size. We still have only one confirmed example of life in the universe: Earth. Finding evidence of past or present life elsewhere in our solar system, whether on Mars, an ocean moon like Europa, or conclusively detecting biosignatures on an exoplanet, would revolutionize our understanding. As Kipping concludes, our next task is clearly to look out and address this question: how common are conditions analogous to those of Earth? That search continues, with each new discovery bringing us closer to answering one of humanity's most profound questions. Are we alone in the universe? And that brings us to the end of another episode of Astronomy Daily, where today we've traveled from the moon's surface to the ultimate fate of the universe, with several fascinating stops in between. We began with Intuitive Machines Lunar Lander Mishap, where altimeter problems and challenging lighting conditions caused their Nova-C lander to topple over in March. Despite this setback, the company is implementing important changes for future missions while diversifying their space business beyond lunar exploration. We then ventured to the far reaches of time itself, with research from Radboud University suggesting the universe's end may arrive in about 10 to the power of 78 years, still an incomprehensibly distant future, but significantly sooner than previous estimates of 10 to the power of 1,100 years. Up on the International Space Station, Expedition's 73 crew members have been advancing biotechnology research and studying fire behavior in microgravity, crucial work that improves our understanding of both space habitation and life on Earth. We also witnessed a historical first with the decommissioning of Galileo satellite GSAT 0104 after 12 years of service. This pioneering event demonstrates Europe's commitment to sustainable space operations and sets a responsible example for constellation management. Perhaps most thought-provoking was our look at new evidence, suggesting life may have emerged with surprising speed after Earth formed. David Kipping's analysis, showing strong statistical support for rapid abiogenesis, raises profound questions about the potential for life elsewhere, even as we acknowledge the rarity of Earth-like conditions. These stories remind us that space exploration continues to challenge our understanding of the universe and our place within it. Each discovery brings new questions, and that's what makes astronomy so endlessly fascinating. If you've enjoyed today's episode, I invite you to visit our website at astronomydaily.io, where you can sign up for our free daily newsletter and catch up on all the latest space and astronomy news with our constantly updating space newsfeed. You can also subscribe to Astronomy Daily on Apple Podcasts, Spotify, YouTube, or wherever you get your podcasts to ensure you never miss an episode. This is Anna for Astronomy Daily. Thank you for listening, and until next time, keep looking up.